Hello, algebra students. Today we're going to be going over the Unit 6 performance task. That's towards the end of the unit. And if you guys just copy down everything that I write and everything I tell you to write, you should write as well. And if you do that, then you'll do well in this activity. So go ahead and turn to that page. Let's see, it starts on page 55 of the Unit 6 workbook. So go ahead and open that now, and we'll go ahead and get started. So I'm going to go ahead and share my page with you, share my screen, and let's go ahead and go to this page here, page 55, and I'm going to go ahead and read it. Please follow along as I read aloud. It says, suppose that you start a business manufacturing and selling luxury beanbag chairs. It will cost you $4,000 to get your business started. You also calculate that each luxury beanbag chair will cost you $50 to produce. Write an equation for the total cost, y sub 1, to manufacture X luxury beanbag chairs. So our equation is going to be y sub 1 equals. Now, what we want to look at is our costs here. So in this case, we have a starting cost, in other words, a fixed cost of $4,000. Plus, we have a cost of $50 to produce each chair. So it's $50 times however many chairs we produce. So it's $50 times however many chairs. So if we produce 10 chairs, then this 50 gets multiplied by 10 because it's $50 for each chair to produce. Plus, there's our fixed costs of $4,000. So this $4,000 cost doesn't get multiplied by X because this is just like opening starting costs. So this is like stuff to get your business started, it says. In other words, this $4,000 doesn't change whether you produce 20 beanbag chairs or 200 beanbag chairs. This $4,000 doesn't change, but this 50 times however many you produce, this will change. So, okay. Part B, you decide to sell luxury beanbag chairs for $62.50 each. Revenue is the total money coming in from sales. So we have our cost equation above. Now we're going to create a revenue equation. So it says write an equation for the total revenue, y sub 2. So we're going to have y sub 2 equals, and then we're going to make our revenue equation. So it says that we sell the chairs for $62.50 each. So that each tells you it's $62.50 times however many we produce, right? So that's $62.50 times X. So however many we produce and sell, it'll be $62.50 times however many. Okay. So here's our revenue equation. So we have our cost equation and our revenue equation. It says, for part C, solve the system of equations algebraically with substitution or elimination by setting y1 equal to y2. So basically what we're going to be looking for is called the break-even point. So the break-even point means that your cost and revenue are equal. So what we're going to do is we're going to put these two equations equal to each other and solve for X. So that's what it says here. Put the equations equal to each other, the cost and revenue equation, and solve for X. So it's going to be $62.50 X equals, and then the cost equation, which is 50X plus 4,000. Okay. Now, in order to solve for X, what I would do first is go ahead and subtract 50X from both sides of the equation. So over here, now we get 12.50 X equals 4,000. Then to get X by itself, we go ahead and divide by 12.50. Okay, so on our calculator, we want to do that. 320. So X equals 320. What does that mean? That means with these given parameters, with this cost and revenue equations, we would have to sell 320 beanbag chairs in order to break even. So that means that we would have to sell 320 chairs, and we wouldn't. And if we do that, then we haven't lost money, but we also haven't gained money at that point. Okay. So that gives you the x coordinate. We also want to find the y coordinate. So what we can do is plug this 320 into one of the original equations. I'll just plug it into y sub 2, which was 6250 x, but I'm going to replace the x with 320. So in order to find the y coordinate, it'll be 62.50 times 320. This will give us that these two equations will cross at 20,000 here. So this gives us the coordinate point where these two lines cross each other. These two lines cross each other at 320, comma 20,000. Okay, that means if we sell 320 beanbag chairs, our cost as well as our revenue will be 20,000 at that point. Okay, part D. Graph the two equations for total cost and revenue and find the intersection point. Okay, make sure to graph only reasonable values for your two equations. Don't forget to label your axes. So the main thing I wanted to point out here is that we need to draw two lines, and their intersection will be at 320, comma 20,000. So since we have two lines that are going to cross at this point, I want to make sure that my graph will show this point. Okay, so we don't want to go by, for example, we don't want to go by 1, 2, 3, 4, 5, because then we'll never get to 320, comma 20,000. Okay, the other point of advice is let's go ahead and make our x and y axis. Our y axis will be far on the left here, like this, and we could do our x-axis like this. Okay, this is where 0, comma 0 is. And now let's think. On the x-axis, I need to at least get to 320, right? So maybe we can count by 20s, and hopefully that'll get us to where we want to be. So 20, 40, 60, 80, this will be where 100 is. 20, 40, 60, 80, here's where 200 is. 20, 40, 60, 80, here's where 300 would be. Okay, and so I'm counting by 20, so 320 will be after that, and then 340 and so on. Okay, so counting by 20s here along the x-axis. And remember, the x-axis is, in our case, the number of beanbag chairs produced. So beanbag chairs. Okay. Okay, there you go. So make sure that you label that there. Now for our y-axis, this will be the money. Okay, so money. Okay, and we need to get up to 20,000. 20,000. So maybe we can count by thousands. So 1, 2, 3, 4. This would be 5,000. Money. We'll put in thousands. Okay, 5, 6, 7, 8, 9. Here's where 10,000 would be. 11, 12, 13, 14, 15,000. 16, 17, 18, 19, 20,000. 21, 22, 23, 24, 25,000. Okay. All right. So let's go ahead and graph the point where these two lines should cross each other. So 320, comma 20,000. So 320 will be right here. and I want to go up to 20,000, which is right here. Okay, so we're putting a coordinate point right there at 320, comma 20,000. So that's the intersection point of these two lines. And now we're going to graph our two equations. So let's go ahead and graph the y sub 1 first. So y sub 1 was the cost equation, which was 50x plus 4,000, I believe, right? Yeah. So now let's go ahead and graph that. So we know, if we remember, y equals mx plus b, our m, our slope, will be 50, and our y-intercept is 4,000. So since our y-intercept is 4,000, I know we'll have a point right here on the y-axis at 4,000. I also know it's going to cross through this point. So what I'm going to do is going to draw a line connecting my y-intercept to this, because I know these 2 points are both on this line. I can go ahead and draw that line. Now, I would suggest using a straight edge, like a ruler or a protractor, something that you could draw a straight line with. I'm not going to be able to do that because I'm on the computer, whatever, but I'll do my best. Hey, that's pretty good. Okay, so this is our cost equation. So I'm going to go ahead and say this is y sub 1. This is our cost equation. Now our the revenue equation, y sub 2, was 6250 x. Now in this one's case, the slope is 6250, and our y-intercept is 0 because we have like basically a plus 0 at the end. So I know the y-intercept is going to be right here, 0. Maybe I'll do this one in a different color. Yeah, let's go red. Okay, so I know our y-intercept is 0, but I also know it's going to have to go through the intersection point because both of these lines go through the intersection point. So I could draw my line now, connecting my y-intercept to my intersection point there. Now make sure to use a straight edge here to make it look nice and neat. My red one didn't come out as good as the blue one, but that's okay. So here's our revenue equation. Okay. Okay, there you go. So here's our cost equation in blue and our revenue equation in red. And I want to point out some things about the graph. So one thing is that when the cost is above the revenue, that means you've lost money. So for example, if you only sell 100 beanbag chairs, you've lost money because the cost is higher than the revenue. You see that? The cost equation is above the revenue. So that means if you sell only 100, you've actually lost money. Okay. But you can see as you sell more, as you go along this, as you sell more beanbag chairs, this gap closes. Eventually you reach the break-even point at 320, meaning if you sell 320 beanbag chairs, you did not lose or gain money. That's break-even. Now, once you've passed that point, notice the revenue equation is on top. So the revenue equation is on top in this case, so that gap is actually good. So this gap means you've actually made that money. Whatever distance the revenue is above the cost, that's profit. Okay, and profit is, of course, good. So you want your revenue equation above your cost equation. Okay, all right. Hopefully that sort of makes sense. Part E, the intersection point on these types of problems is sometimes called the break-even point. I've already been talking about that. Label this on your graph and explain why the point is called the break-even point. What does the intersection point mean in this problem? So I've already kind of explained that. And if you, and I'll explain it again, but this is the break-even point, so you want to label that here. Maybe I'll use another color here, maybe purple. So this is our break even. Okay. Here's our break even point. And I've explained the importance of it already, but to explain it again, basically, this point represents the point at which the costs and revenue are equal, meaning at this point, you have not gained money, but you also have not lost money either. So if you sell 300, in this case, 320 beanbag chairs, you've spent 20,000, but you've also brought in 20,000. So then that way you haven't really lost any money, but you also haven't gained any either. So I want you to just basically explain that in your own words right here. If you aren't sure how to explain that, then you can go ahead and rewind the video and listen to me explain it again. Write an inequality to describe how many beanbag chairs need to be sold to make a profit. So remember, our break-even point was 320, comma 20,000, right? So if I sell less than that, less than 320, then you actually have a loss. You've lost money. If you sell exactly 320, well, you didn't lose or gain, you broke even. But if you sell more than 320, then you start to gain a profit. So, write a compound inequality to describe the number of beanbag chairs sold that would result in a loss. So first, for a profit, the number of beanbag chairs we need to sell needs to be greater than 320. Okay. It says write a compound inequality to describe the number of beanbag chairs sold that would result in a loss. I don't know why it says compound inequality. Just write an inequality to describe the loss. So if your sales are less than 320, then that'll result in a loss. Okay. And that's it. Okay. Well, I hope that made sense. Hopefully you're able to get through it relatively painlessly. And if you still need help, you can feel free to email me. My email is ttrigg@ofy.org. All right. Well, with that, I'll see you guys next time.